Hello, I'm Jacob from the Cedar Pacific Library, and today we're building a speaker. Not this one specifically, but a smaller, simpler one. Because before you can build something big, you have to understand it enough to make it small. The original speaker actually wasn't really a speaker, at least not the way we know it today. It was a cone, at least, well, partially. Created in the late 19th century, the device was originally known as a phonogram, and would eventually become to be known as a gramophone. And it actually took no electricity to function, instead relying on a winding crank for energy. Perhaps the most delicate part of the phonograph was known as the reproducer, which contained both the diaphragm and the needle. Both were connected by a small copper wire, so that as the needle ran over the grooves of the phonograph recordings, either a cylinder or a flat disc, it would vibrate slightly. The copper wire would transfer this mechanical vibration into the thin metal diaphragm, where it displaced enough air to create an audible sound. From there, it would push its way through the cone, where it would be amplified enough that it could easily be heard across an entire room. This method of projecting sound was among the first of its kind, and while technically amazing, the quality of the sound left quite a bit to be desired. Due to the simplicity of the diaphragm used to create the sound, as well as the use of the metal cone to amplify it, the audio quality was muffled, stiff, and often extremely distorted. Over the next 40 years, inventors across the world would tinker and try to improve the design of the gramophone. And as much as progress was made, the design itself was naturally limited in the quality of the sound it could create. Then, around 1924, a couple of researchers from General Electric, Chester Rice and Edward Kellogg, no relation to the cereal, patented what remains the basic design for virtually all of the world's speakers, one that used electromagnetism. Known as an electromagnetic speaker, these speakers allowed for greater volume and clarity, and they very quickly replaced the cones that sit on top of record players around the world, and for a very good reason. Not only were they just plain better speakers, they were also deceptively simple to make. The first thing we need when making this type of speaker is a diaphragm, also known as a cone. Unlike the thin metal diaphragm used in the phonograph, modern speakers have a semi-rigid diaphragm that is able to vibrate across a much wider frequency. In professionally made speakers, these are made with specifically designed materials, but the concept is simple enough we can demonstrate it using plastic cups. You can also use a paper cup, or pretty much anything else that's durable enough to react to an electric current without breaking. Now that we have our diaphragm, we need to create our electromagnet. This is done by taking an enamel-coated copper wire and wrapping it around in loops. When this wire is wound together, it is known as a solenoid, and when connected to an electrical current, it creates what is called a temporary magnet. Today, we're going to be getting both the electricity and the sound from the audio jack on my phone. Now that we hypothetically have our electromagnet and our cone, what sort of sound is our speaker going to give us? To find out, we're going to first take our solenoid and tape it to our diaphragm to make sure all of our coils stay at least in relatively the same order. Then we are going to take a piece of sandpaper and gently remove the enamel from both ends of our solenoid. Next, we are going to connect a pair of gator clips to each side. Finally, we are going to connect both gator clips to one of the exposed ends of my aux cable before plugging the non-clipped side into my phone. The result is virtually non-existent. The reason for this is that on its own, the copper wire is nowhere near magnetically strong enough to produce the current necessary to displace the air required to make sound. Now, watch what happens when we add an extremely powerful magnet to our solenoid. And just like that, we have created a simple electromagnetic speaker. The electricity flows through the coils of the wire to create an electromagnet. This electromagnet is attached to the cone. As the current flows through the electromagnet, it is quickly pulled towards the permanent magnet and then equally quickly repelled from it, pushing the cone along with it, thereby creating sound. But after getting the first speaker to work, it naturally begs the question, what about two speakers? Nice, easily done. But what about 5? Wow, once again, easily done. And with almost no drop in sound quality, you can really tell how much weight the magnets are carrying in the creation of the sound. Now, while our speakers are rudimentary and don't have the clearest sound, they use the exact same scientific principles as the professionally built speakers. So much so that we can connect these speakers the same way we did our plastic cup speakers and get the exact same results. Thanks for watching.